are you guys enjoying the conference so far? Everyone, thumbs up? Cool, all right. That's exciting. So my name is Brian Guthrie. I work for ThoughtWorks, and my partner here can introduce himself.
Yeah, I'm Srushti Ambekallu. I'm from C42 Engineering. We're a boutique boutique Ruby consultancy from Bangalore.
And I have flown out here from Melbourne, and Srushti has flown out here from Bangalore. So I think that I don't know. I mean, I think it's a far way, I guess is all I'm saying.
Yeah, you have two very jet-lagged presenters in front of you.
Yeah, I was going to try to claim the crown of most traveled, but I know you have other C42 guys here from Bangalore as well, who have come about in fact, exactly as far as you've come.
Yes.
So, well. Anyway, so we're here today to talk about Ruby software continuously delivered and exhaustively explained. And I guess by exhaustively explained, we mean that we're going to try to cover as wide a base of what we think you guys need to know for an introduction to continuous delivery practices in Ruby as possible, but it's not going to cover everything. There are topics we're not going to touch on. There's a great book out there called Continuous Delivery, written by Jez Hummel and Dave Farley, which is the inspiration for a great deal of this stuff, and I recommend that you all run out and go buy it and read it because it really is a really good read. But this will give you some introduction to a lot of what that book talks about, and also with a sort of Ruby cast on it, because that's what we're here to talk about, and it's what we like doing. Yeah. So let's get going. So by way of credentializing ourselves a little bit, my friend Srushti here is the author I guess one of the authors and maintainers of a continuous integration tool called Goldberg that C42 has released. It's a nice, simple tool for doing CI. You guys should all go check it out. Whereas I, on the other hand...
Brian here is the primary maintainer currently of Cruise Control RB. I'm sure everyone's heard of it. But if not, it's definitely one of the most popular CI servers out there. Easily one of the first Ruby, if not the first Ruby CI server. It's
not under a huge amount of development right now, but it is actively maintained. We both welcome your your commits and your love and attention. They're both nice pieces of software-ish. Anyway, so we wanted to start out talking about where this sort of lies in the spectrum of release processes. I don't think this should come as a particular shock to anyone. I mean, how many people have ever been on a project like this before? You have, okay, so we have a few folks, right, where you have an early sort of very staged development cycle, and then you have a distinct testing cycle and a distinct user acceptance testing. And this thing spans over months and months, right? This is sort of pre-agile, traditional waterfall style, very rigid process. And in this model of release and deployment, you're getting customer value very late in the process, right? It takes several months, it takes, or even a year. You go through a lot of phases along the way. It's very expensive and it's very risk prone. At one point, it was seen to be very rigorous and engineered. But I think over time, as software practitioners, most of us have come around to the perspective that there's more risk involved rather than making the process more disciplined. It makes it less disciplined.
So we decided to move that forward by applying Agile principles. So basically, we decided to, instead of waiting for 3 months, 6 months to get stuff out there, get stuff into production and see the value of it and stuff, we would do it maybe once every iteration. Yeah, we integrate constantly. It's not like we wait near the end of the release to put all the code together, no long-running branches, that sort of thing. So we're always, all the code is always in one code base, no branches, that sort of thing. And keep pushing this stuff out to some sort of testing environment. Maybe the testers can pull down the code and test it on their own machines, gather customer feedback once every few days, and actually push to production once an iteration maybe a little little rarer than that, but something along those lines, an iteration being typically 1 week or 2 weeks. So yeah, and we thought that was definitely an improvement. Everyone saw value in that.
But as you can tell from our clever use of color here, and of the colors specifically red, green, and yellow, we're moving in a direction in which all of this stuff is continuous, right? Where things just happen all the time, where we're trying to get into production as quickly as possible, staying within the spirit of delivering value constantly, rather than waiting 2 weeks to deliver that value, finding if we can build a process collectively for delivering that value in a continuous manner. And in order to build this kind of process out, we really have to be able to answer as a team, as practitioners, and to our clients and customers, I think 3 questions satisfactorily. In order to be able to go live all the time, we have to know that the code that we're deploying is correct in the sense that the logic that we've written actually works the way we intended it to. And we see that as primarily driven out with a TDD-style process or a BDD-style process. Is the deployment process itself safe? Will going live cause any problems for us, or will we be able to do it in a stable fashion? And is the work that we're actually pushing live valuable? Are we building out features that customers want? Are they the right features? Are we making things visible that shouldn't be visible? Pushing the wrong thing out actually has negative value.
And specifically for this audience, we're looking at why is this important to us specifically? Why is this more valuable to us? What aspects of Ruby actually make this so much more interesting to us? Ruby has generally been in the forefront of the Ruby community, I should say, has been in the forefront of being able to get stuff out there as quickly as possible, being able to get from idea to a finished product that much faster. So there's a symbiosis. There's a real connection between continuous delivery and Ruby development. But I'm sure there are things we could improve. There's always room for improvement. So yeah, we'll try and focus on that a little bit now.
All right. So as part of the way we've structured this talk, we are going to be playing a couple of personas for you, and hopefully that will work out okay for us. So Srushti here is going to play the part of the noble, virtuous, paladin-style dude, and I am going to be that.
Yeah.
And it's going to be great. Well, okay, maybe it's going to be. It's probably going to be great.
Right.
All right.
So being the
That's a terrible introduction. I've got to work on that.
Being the virtuous person trying to be all safe and be cautious, I would say one of those aspects that we really, that's really important to continuous delivery is continuous integration. The thing that preceded continuous delivery. Like this is what we talked about earlier about is stuff working out there. So I think I'm preaching to the choir talking about how testing is important, but let's
Hulk no need tests.
Yeah.
Hulk code perfect first time.
All the time, Hulk?
All the time, 100%.
Has it never broken in production?
Well, 97% perfect first time.
And what about the other 3% of the
3% catastrophic failure, approximately.
So what if we could do something to avoid that 3%?
Hulk mistrustful, but willing to listen.
Yeah. So let's consider that 3% as a hapless commit out there, trying to get through the maze into production.
So how many of you have seen the show Takeshi's Castle before, or Most Extreme Challenge? So that's the inspiration for the slide.
Yeah,
I think.
So every commit wants to go into production. That's its primary purpose. It's dying to get there, and it's the only way it feels it can fulfill its purpose. But not every commit deserves to be in production. There are some bad commits out there that you don't want to get out there.
Hulk no like bad commits.
There we go. So we have to find something to prevent these bad commits from getting into production. And those bad commits are, and those guards are tests. Mr. Fail here, hiding along the way before the commit can get into production where it doesn't belong.
Do you like our gold star on production there? Woohoo! Sorry.
Yes. Someone said it better than we could. So CI is primary. CI would, every commit in CI would be giving rise to a release candidate, but the job of the CI system is to disprove the production readiness of a release candidate. Basically, your CI system, continuous delivery system, should be in place to prevent those bad release candidates from getting into production, and that should be its primary purpose.
So that's assuming that you aren't already writing perfect code.
Yes.
But for those of us who are,
yeah.
Okay, we can safely ignore this.
Yeah, you don't need it. But for the rest of us, for the mortals out here,
Hulk just making sure.
Yes. Right. And okay, so let's go over the different kinds of tests. Again, a lot of this is pretty obvious, but let's just make sure we're on the same page. Unit tests. basically is test as close to the individual modules as possible, smaller methods, just right next to we are testing pieces of code, pieces of logic in isolation and all by itself. Integration tests, are they working well with the rest of the code? But still, we're talking about the tests are still at around the same level, but it's just a few more layers together. Functional tests, now we're going a little bit higher, looking at it from the end user's point of view. Stuff's still automated, but you're going through the browser, clicking on things in the web app. Obviously, it'd be the browser. Otherwise, clicking on the rich client applications, whatever it is. And then, there are manual tests. We want to avoid those. We want to minimize those, but sometimes you can't help it. There are things that there is value there, but so have an actual person test it. And once you actually get the stuff into production, you want to make sure nothing is broken. So maybe run a couple of reversible kind of tests, and if need be, have a way of rolling back those bad commits if somehow they manage to get through all these other 4 steps. So traditionally, this is how.
Once again, clever use of color.
Yeah. So this is how you would. This is how most systems function. Very few unit tests, if at all. We went back and forth on what we meant by manual unit tests. I think it's just running the code directly through like IRB or something.
In the narrow sense that you're testing the logic of the code rather than testing it from the user standpoint, right? So anyone who's ever exercised code through a REPL, right, through something like IRB, to me that's an example of a manual unit test. That is something that you're purely focused on the code, but to take those and to freeze them turns it into tests that have value. Not the REPL tests don't have value, but that you retain them over time. They're stored in source control. They change when the code changes, etc.
Yeah. This is traditionally how projects were. Projects were built around. But what we want to get to is a lot of unit tests, fewer functional, fewer GUI. So again, this is something I think we all already do, but the thing to focus on, and this is something I fail to do quite often, is when a bug does get into production, we know the thing of write a test for that failing scenario and then actually fix the damn thing. But I would take that one step further and say, if your unit test pass but something fails in functional or later, actually try and figure out if there was a unit test missing. So maybe your Selenium test failed. And there might be a very good reason it cannot be tested at a unit level. There is something about the whole, all the systems together, which means, there's a reason you have functional tests. So, maybe this couldn't be tested on a unit level, but every time it does fail at a later stage, make sure there was no, you didn't miss something, and there was a specific kind of test that you could have written at a higher, at an earlier stage in this build process. So what are we talking about, right? When we consider these different stages of the build, we're talking about unit tests, integration, functional, that sort of thing. If we actually put that into an automated process, we get a build pipeline, which, again, from the continuous delivery book Brian talked about earlier, it's an automated manifestation of your processes, of your process for getting software from version control into the hands of your tests, right? This is stuff we already do. So we always had a pipeline. Mentally we always knew we had to go do this first and then that, and then, maybe it was a README, maybe it's, stuff that you just happen to know.
Hulk thinks automated manifestations sound very abstract.
Yes.
Looking for more concrete description.
Yes. So this is how a traditional CI system worked. So every commit that went through, went to your version control. In our case, we like GitHub. And your CI server keeps polling for changes.
You'll note that I cleverly inserted a screenshot of CCRB in there.
Yes.
So that's the penalty of not paying too much attention to the slides, is that.
But it's too small. I don't think anyone can
That's
tell.
true, yeah. But I've just called it out, so.
So now everybody knows. Yes. So your CI server keeps polling, version control sees if there's a new commit, and then runs through those tests that we have. Again, before pipelines came around, you just had one long, build perhaps, which ran 3 rake tasks.
Well, to me, I think the important connection here is that I've seen a lot of CI systems where automated deployment simply wasn't part of the process, right? That CI was simply a source of information about your tests. And the notion of a pipeline is that you're integrating the next stage, right? That there is an output from your build, that there is a deliverable from the result of running those tests, which is that you move into the next step.
Yeah, exactly. So the next stage of this, what we are introducing here, from your CI system, is to actually go live with those changes that you have, assuming all the tests pass, and you have complete confidence in your tests. And if you don't, go back and write those tests. But assuming you're happy with, assuming all the tests pass, of all these different kinds of tests pass, push stuff to production, and then obviously run those smoke tests that we talked about.
So Hulk was talking to a fellow last night who was running through a continuous delivery process, and so we asked him, so we assume you have a really robust, crazy test suite strategy, right? And the guy was like, nah. So one of the interesting things that I get out of conversations like that is that you can do this without incredibly robust automated test suite like we're looking at here, but you are running a risk there. We recommend tests.
Yeah, I mean, the temptation is to, when you're prototyping things, maybe say we don't need tests, and once it actually, something sticks and you want to actually proceed with it, go back and write those tests. So aside from the fact that tests serve a purpose beyond what we're talking about, beyond the regression nature of it, to drive design and to make sure your code is modular and then all the rest of it, just from a discipline point of view, it helps to make sure your code is always tested and so everything is stuff doesn't get messed basically.
All right, next.
Yes. And obviously, like we said earlier, you would like everything to be automated, but there are just some scenarios where you can't, honestly cannot test everything in an automated way. Beyond just the fact that you want your, there might be bugs, you want to gather feedback from the end user point of view, maybe the design is slightly off, things like that. You have that middle step where you push stuff to staging, manual test it, production, deploy again, and the smoke test right at the end. The real value of the pipeline comes in not just having serial steps where one thing flows into the other. And in some places, you do need them to flow into each other because they're directly dependent on something before. But very valuable thing is to be able to parallelize it so that your wait time is just as long as your the single longest step rather than the sum of all the steps. Definitely do that because machines are, we say this all the time, but we don't necessarily practice it. But machines are way less valuable or cost way less than people's time. So
one of the things I did want to mention in here is that the inspiration for the term build pipeline is actually CPU pipelining, in which you attempt to execute certain instructions, optimistically, right? If you're trying to string operations together, you want to, rather than doing them all serially, execute them in parallel, assuming that you'll find the one that you want. And one of the ideas behind build pipelining to accelerate your build is to execute these builds in parallel, assume your unit tests will pass, and just move on and do the integration and the functional at the same time.
Mm-hmm. Yeah, and worst case scenario, one of them fails. It's not like you wasted anything anyway. So.
And a corollary to that, I think, Srushti, I don't know if you want to talk more about this, but the idea that the CI server is not just sitting under someone's desk anymore, right? This is now a first-class part of what it is that you do and how you interact with your software and how your customer understands what your software is doing.
Yeah, exactly. So until now, CI has been like a theoretical thing that developers cared about. It's something we make. The only value of it really was that when you committed, you knew you hadn't broken anything to the extent that other developers wouldn't be blocked from pulling in code and working on that. But now, if you're gonna rely on it to make sure bad code doesn't get into production, it's so much more important, and you need that extra level of confidence. I mean, I think Jim Weirich asked this question yesterday about how many people could sleep happy tonight if they knew overnight your code is going to get pushed into production. We'd like to think we would be, but how many of us really would? And so
last night I spent a lot of time worrying about this talk getting pushed into production. Actually, that was not sleeping too happily in that one.
Yeah. And I had a very bad commit just a couple of days back where stuff got broken and we had to roll it back. So I'm speaking from experience where I'm talking about not having the right number of tests. Basically, you have to promote it from something that's just something that developers practice to something that your customers are going to care about, your end users are going to care about. It's something it reaches a whole other level of importance.
So,
yeah, you want to?
Yeah, if you don't mind too terribly. So if I may move into chill mode for a moment, perhaps that's the right term. My employer, ThoughtWorks, makes a professional CI tool called Go. I haven't worked on Go myself, but it's quite a nice tool. I've used it before. And the whole point behind it is to attempt to take this build pipeline notion and the continuous delivery process and build something that's centered around it. Yeah, I mean, if that's something that you're interested in, by all means, go check it out. It's commercial. I think it's free for individuals to use, but you get to a certain size, you're going to have to pay something. Just throwing it out there.
Yeah, I think it's for parallelization, multiple agents, that sort of thing.
Yeah.
Yeah, and this is doesn't really fit in here, but we like the animation. So yeah, basically your manual test.
That's definitely the best reason for including a slide in a presentation is if you like the animation.
Yes, you type a little bit, it click around.
This is manual testing, by the way. We should say this is an example of manual testing. Yes.
You type some more, click some more. You keep doing that, and then finally, error.
And that's what the QA looks like. And then the dev on the other side. Anyway, that's what I usually look like after the QA finds a bug in my code.
So we just kind of skimmed over deployment, putting stuff into production.
Let's talk about some more.
Yeah.
Is that what we're proposing?
Yep.
Yes. In fact, we have a title slide for that. So deployment, right? If you get nothing else out of this talk, we do want to touch on the DevOps thing, right? A lot of where this movement is coming from is from large organizations that have more separated dev and ops capabilities. If you're coming from a startup background, this probably isn't a problem for you. You probably have a bunch of multi-skilled people who are all physically in the same room and they're all talking with each other constantly. At a lot of organizations, that's not the case. One of the goals of the DevOps movement and one of the prerequisites, I think, to doing proper continuous delivery, especially at these larger places, is to try to bring these folks together, build bridges between these organizations. And a lot of what I'm going to be talking about in the next few slides is going to be about changing the deployment process and specifically some of the things that Ruby does with deployment to attempt to improve sort of the dialogue that you have with ops folks.
Hold on. You're saying you don't want people to specialize on certain skills? That seems a little scary. Yeah, jack of all trades.
No. Hulk-like generalists. Hulk smash specialists.
I need you to convince me on this. Go on.
Okay, well, I don't think you should have a separate deployment team. I think if you have a separate deployment team, you're doing it wrong. Deployment is something that everyone owns, that everyone's responsible for. Hulk smash deployment, I think, is the message there. But collectively, we smash it as a Justice League team. Is Hulk part of Hulk not have good understanding of canon?
No, yeah, we have a DC Marvel crossover going on.
Oh, shit. Okay. Oh, sorry. But anyway, so that's okay, though, because deployment is super easy in Ruby. And this is another slide that we included just for the animation. So here's how I deploy in Ruby, right? Hulk is all about doing it like the baddest ass way possible. So I'm all like, I SSH root into production, right? And I'm all like cd var site, git pull the commit out, I'm bundle installing, I'm rake db migrating, I'm jam it packaging, touch temp restart to text, and that's it, And I just do this on all 18,000 servers individually, but I can do it in parallel because I just get, the flash in there or something. He takes care of it. No. Okay, so right. Obviously, this process doesn't scale. Right? There are good reasons to automate. We're all on the same page here, right? I don't think anyone here is going to argue that automating your deployment is a bad thing. Except you, it's not in your person. You're pretty cool with automating. I think Superman's all about that.
I just don't want to do it that often because it's a little risky.
Sure. Yeah. Well, we're all about taking this thing down to that thing, down to that thing, down to that thing. Right? We think we can do this once every 5 minutes. How does Superman feel about that?
Convince me.
Convince you?
Yeah. I think it's still risky, so...
Hulk no need convince. Hulk smash Superman. No, that probably wouldn't work out well for me.
It's not going to work. Go on.
So here's what Capistrano does. Capistrano essentially takes something very similar to that. It doesn't actually... You shouldn't be SSHing root into production. Stop doing that. But it takes that whole process and sort of automates it, right, to the point where you have a script that runs through all that stuff for you. But to me, there's a lot of those things that really don't fall into the category of stuff that you need to be doing as part of a cap deploy. There are things in there that should probably be moved down into your CI server. I think one of the things that we don't do in our CI, at least I haven't done on my past Ruby teams, is really use the opportunity of having CI to build an artifact and to push that artifact out as the unit of deploy. And things like resolving dependencies beforehand, turning your Sass and your CoffeeScript into actual web languages. This stuff can be done and built out in a previous place. And doing that, right, these three things, these are all things that I think can and should happen earlier than that. Deployment involves pushing the thing up and then using the new thing. Bundle install doesn't need to be part of deployment. Converting the things Sass and CoffeeScript does not need to be part of deployment. Look at build a binary, right? Build a tarball, use your operating system's native packaging format. I've even heard of some folks building a gem out of their deployable artifact and releasing it that way. You figure Rubyists already have a perfectly decent package management system of their own. If you don't want to use your operating system's server, run your own gem server. And then that way, it solves a bundler problem too, because you always have the versions of the gems that you need available to you.
The thing to be careful about in this is to make sure your CI server, CI machine, we already know the staging needs to be as close to your production machine as possible, but this will also mean your CI has to be as close to your production machine as possible. Same OS, same Ruby version, patch level, everything, so that there's none of these problems when you push stuff into. Right.
Part of reducing the risk of the deployment process, if you are going to do this thing where you go out and you build a package, is that your CI server should match your prod environment as closely as you can. It's a risk thing. I mean, I don't know. Has anyone here ever had test failures before that were based on CI environment or testing environment versus prod? Yeah, I've seen some hands and some nods out there. So yeah, I'm probably preaching to the choir there as well, but I think it's an important thing to remember anyway, because I forget it sometimes. And how much do you automate? You automate until you require human intervention, right? Until a decision is required. So at some point, someone should have to physically click the button to go out to production. But up until that point, right, all the rest of that stuff can and should be automated. The actual go live, I think, can safely be done only by a human who can make the call. Are we ready? Yes. Go ahead and click deploy. And many of your better release management packages will have some sort of mechanism for that, right? Maybe there's a password involved or authentication or some sort of control around that stuff. A few things that Rubyists install in prod right now, a few other things that Rubyists install in prod right now that probably don't need to be there. GCC, right, not for production. RVM, I love RVM. I think it's a great dev tool. I don't think you should be running it in production. Git, don't need it in production, right? These are things that part of the DevOps conversation is talking with your friendly neighborhood ops folk about how to reduce the risk of the things that you push out there and make available live. My friendly neighborhood ops person within ThoughtWorks, when he heard that I was saying you shouldn't install GCC in production, he almost broke down and cried. He was so happy to hear me say that. Because he and I had thought about that before, but I've come around. I mean, I think it's one of those things that, yeah, it seems simple and easy and straightforward, but you're reducing the risk profile of your prod servers the less stuff you have installed on them. There's also Chef and Puppet, right? So part of we're not going to get too deeply into this because neither of us are Chef or Puppet experts, but configuration management helps make deployment safe, right? You should start to think of your servers not as works of art, but as things that you're going in there and version controlling, check everything into source control, make sure all that stuff is managed in a safe way, and deploy the same thing the same way to every environment. So you can build one binary, build one tarball, whatever, deploy the same thing to every server that you're going out to, make sure all of those servers are configured the same way using Chef or Puppet. You can do continuous deployment without this stuff, or continuous delivery, I should say, I suppose. But it's one of those things that helps reduce your risk profile for the deployment stage of this stuff.
Yep.
How does Superman feel about that?
I'm coming around, yeah. I
Okay.
think if we automate enough, all that risk is gone. So yeah, maybe it's safe enough.
5 minutes? 5 minutes, you think? 5 minutes?
Yeah, possibly, yeah.
I did want to call out a tool called Deploynator, which I think is super cool. This is the thing that the Etsy guys are using to do their, as part of their delivery process. It's open source. I believe it's available up on GitHub. I haven't used it personally, but it seems super neat. So I'm all in favor of things that are super neat. I love the Save the Princess button there. Apparently they used to have an environment called Staging, but then they built out another environment that was also called Staging, so they had to rename the old environment, so they named it Princess, which as far as server names go, isn't bad. So the final thing that we wanted to touch on and get into, and I think that this is probably the most topical topic from a Ruby community standpoint, is deploying the right stuff. And how do we make sure that the thing that we're pushing up into production is valuable? How do we make sure that we're not pushing the wrong features out? And so we're going to talk a little bit about feature branches and feature toggles. But before we get into that stuff, do you want to talk about mitigation strategies?
Yeah, so the reason any of this stuff is important, either of feature branches or feature toggles, is you have long-running tasks. You have stuff that takes more than a few days, more than one day to get done, and you'd like to be committing all along, and that sort of thing. Maybe even collaborate with others, and so.
Well, do you want to explain the terms? What is a feature branch?
Yeah. So for those who don't know, a feature branch is basically you create a branch just for one individual feature. Maybe it's just on your
like
machine.
a source control branch, yeah. Source control,
yes, exactly. So obviously with Git and Mercurial and all these things, and I don't think anybody uses anything but Git. It's pretty trivial.
Yes,
and
yes, for you 5 Mercurial people in, I don't know, the next city somewhere.
I think PyCodeConf is a week down the line. So
oh, okay.
That's Mercurial.
Well, in that city then, yeah.
So because branching is so easy with.
I love Mercurial, by the way. I don't mean to. I'm just joking because
because they're not here.
Hulk totally cool with both source control management systems. Hulk agnostic in that regard.
So since branching is that easy, people end up using it to keep you keep the code separate. The stuff that's in process, you kind of keep it separate from your master branch that's going to go into production. On the other hand, feature toggle is you keep the code all in the one branch and somehow turn off the functionality with a flag or something, which can be turned on if need be, whenever it is ready. And these are for long-running functionality, long-running development stories, because you don't want to deploy half-baked stories. But maybe we don't even need that. There's a few things you can do. One thing is push for smaller features. Break every feature. I mean, you talk to the people defining these features to see if we can break it down to smaller tasks that can be done, and you get value as you're building it, rather than wait for a big thing. There's almost always a way to do that. I mean, even if you have big features, make them into smaller tasks, each of which, like I said, gives you value, each of which is testable and on its own, and it's not going to break anything. It's a little hard to do the BDD without, little hard to do with BDD because business actually, it's business driven. But you want. But
so what do you mean by business driven then? Why is it hard to do with BDD because it's business driven?
Because until you have the UI, so basically what we're saying is to add the UI last so that you can do all the other stuff and nothing is reflected on the screen. But if you do that,
so the BDD approach is top down, right? You start with the UI,
exactly,
you drive your way in.
Exactly, and but if the business doesn't actually get to see it, it's not really business driven anymore. So your mileage may vary on that. Finally, branch by abstraction.
So branch by abstraction is the notion that you can insert an abstraction layer between the pieces of your application. Gosh, how to explain that? We should have had a diagram for that because that requires a diagram. But the notion is that if you have a really big change that's coming into your application, say you're changing the ORM layer, you build an abstraction layer between your application and the ORM layer, and allow that abstraction layer to toggle between the two alternative implementations, build out one while you continue to maintain the other, and then eventually you're in a position where you can swap over from one to the other. I think of feature toggles as being kind of a special case of that, but branch by abstraction is really one of those concepts that's very helpful for large, difficult changes. That having been said, I don't think you could do branch by abstraction with something like a Rails upgrade. I've done nasty Rails upgrades before, and that's you can't abstract away the framework, right?
Yeah, exactly.
Anyway.
Yeah, so the GitHub flow model, which as far as I know, they use for everything.
Yeah, so I hope this is correct because we tracked down Zach Holman last night at the AMP block party and physically assaulted him with questions about this to make sure it was okay. But we didn't actually show him the slide. But this reflects sort of our understanding of how they're going about building features into GitHub.
And also should be pointed out that we were all possibly a little drunk, so.
Yeah, that's okay. So we'd had a couple beers by that point, and then we had to identify who exactly he was by his Twitter photo, which was fun too. Going around, have you seen this man? Showing the iPhone. But eventually, we did in fact find him, and he was very gracious. So thank you, Zach.
Yeah, he's not here, I don't think.
I don't think so either.
Basically the way it works is you have your master, you fork each of your branches from there, and work independently of everybody else. Once it's actually done, a day down the line, a couple of days down the line, or even maybe within the same day, you give a pull request, or you push, you're assuming you have access and that's the process, you push directly into master. And then it obviously goes into production. The way this works with multiple people is you are, so say Brian starts on his search form functionality. A little bit down the line, I decide to work on a separate piece of functionality, which is a different search form. I start a little bit later, but I don't have his changes. Halfway through my working on it, I still don't have his changes, although he's been making commits on his branch.
I don't understand that release bar there, though. I feel like that arrow.
So I'm rebasing from master. I have all these other changes.
Rebase. That's what it says. Okay, yeah.
And I'm getting changes from master throughout, but I'm just not getting any work done, any of the work done by Brian on his branch, and any refactoring I'm doing along the way is going to get broken by, or is going to break when eventually I have to merge back into master. So once my features are actually done.
So this is a general issue with any feature branching strategy that relies on relatively long-running branches. My understanding is that GitHub manages to avoid most of this stuff because they run CI independently in each branch, and they tend to not leave them around for very long. They're not long-running branches. They get them in quickly. But there are certain kinds of semantic merge conflicts that Git, as awesome as Git is not capable of resolving. In practice, they don't happen all that often, I don't think, but when they do happen, they tend to get pretty nasty. And that's when two people independently refactor the same piece of code or change it in some other meaningful way and are later unable to resolve those differences without a lot of painful munging and crushing and general agony. In the case of def foo renamed to either bar or baz, that's not a whole lot of agony as far as these things go. That's a pretty mild, like sort of mosquito bite level thing, unless you have 18,000 gazillion people calling that method. Exactly. In which case you're in trouble.
Yeah, but you try and rename model or something and have everybody referring to the old place. It's just things just go out of whack. If you start doing migrations in individual branches, that's if they're somehow affecting each other, then you just can't. It's not a version control conflict now, but it's something much more fundamental. You actually might have to go back and rewrite those migrations and somehow make it work. So,
but as Zach and I think the rest of the GitHub guys would point out, communication is a good mitigation strategy for this, right? If you're talking constantly, if you're chatting, if you're making sure that if you're undergoing large refactorings that you're in communication with the folks around you, you can prevent folks from getting off hopefully too far into the woods with this stuff.
Yeah. So, but to kind of avoid this and maybe not do this all the time, we could go with the other way of
the other way. So, yes, probably click that slide there. So most of the folks that I work with are big fans of this strategy, which is a very traditional CI-oriented, just commit everything to trunk or master, as the case may be. The spirit of CI is that everyone's changes are visible to everyone else all the time. That everyone has the latest version of the code, that no one's out there working in isolation for days and days, that you're constantly merging into the same spot. And the folks that I've talked to seem to think that this is, especially as your team starts to grow out, a safer strategy for doing continuous delivery, that the more people you add to the team, the more risk you're running that someone's going to run into sort of long-running feature branches that go a little longer than they should. The harder it is to coordinate and communicate around what changes might be occurring. This is not without its problems, right? But in this particular case, the diagram is trying to show that, well, okay, so B. Guthrie submits a commit, and he pushes into master. Srushti rebases, and he gets that commit, brings it back down again. And the other nice thing about using this rebase model as opposed to a merge model is that you end up with a very straightforward commit history, right? It's very, very simple. There's not a lot of arrows heading in and out of master. I happen to really like this. I know Git's really powerful in that regard. I don't think that that's the kind of power that is necessarily helping you much. But again, it's not without problems, right? So if I insert a feature toggle and other people insert a feature toggle, eventually you're going to get, merge conflicts, right? I think that's what that's trying to say there. For long-running features, for things that you do not want visible to the user interface, that's an example of what I'm talking about right down there, right? It's if the masala feature is enabled, then we render a masala dosa, which is more delicious than a plain dosa, I happen to think. Yes, it's got some agreement from the audience there. So feature toggles, the trouble with feature toggles and the trade-off that you're making there is that they tend to get crufty, right? They accumulate. You have to be very aggressive about removing them. If you don't remove them promptly, they can accumulate in nasty ways. But you get two big benefits out of them, though, right? And one big benefit is that you start to have a conversation about enabling and disabling certain features. Feature toggles aren't quite the same thing as enabling and disabling features. I mean, that's sort of a separate category of if you want to be able to turn off email in your system or whatever, that's sort of that should be intentionally built in, and there should be a mechanism for that. But you can start to have a conversation with the business about what parts of our site can degrade gracefully, and how can we build out a process for doing that. And the other huge advantage of feature toggles, I think, is that you start to decouple deployment from release. So that deployment or release are no longer the same activity. You can be deploying code and features that, while it's physically present in the code base, aren't yet released out to the public. And that is another strategy for making your deployment process safer, I think, in the long run.
Yeah. The thing to be careful about is there's some. So we're showing a very, very trivial example of a feature toggle here, something in the view it either renders or it doesn't. But it could get a lot more complicated than that, and you might even miss some aspect of, like, there's some calculation which now has to consider a new kind of tax or a new kind of some new number there, and the code just starts to get really complicated. Your tests around it, because you'll have a test for the situation without the where it's toggled off, another one where it's toggled on, and and so, like, there's the limitation obviously of screwing it up where you forget to toggle something off further down the line, which is not immediately apparent on the screen, and now you have something half finished in production. But yeah, your tests start to get really complicated as well. So a couple of negatives there.
Yeah. Well, did you address testing positive and negatives of feature toggles as well? Yeah, you should write tests to ensure that you're testing with the application with them enabled and disabled in both states. Otherwise, you're not fully covering yourself, I think.
Yeah, and if it just makes it easier for your staging environment. If you can turn it on and off, you have feedback on features as it's being developed. Unless you set up another staging environment for every single feature branch that you build, which you could, but it just adds that much more of an ops overhead to everybody. But if if it can be turned on off trivially, you gather feedback even if before the feature is finished, and you can go back and fix it. And as we all agree, I think quick feedback is always better.
I was going to make a Hulk joke about that, but I think Hulk prefers quick feedback as well. So finally, I think the final piece we wanted to talk a little bit about here is in the Git community, there's developed a bit of a taste for really Baroque branching and merging models. I think Baroque is a good way to put that. This seems to be working for. Does anyone follow a release process like this, like the Git flow stuff? How do you guys like it? No. With Perforce? Okay. Apparently the fellow using Perforce is not from Seattle. We've confirmed. This appears... You like? Okay. I mean, it appears to be working well for a lot of people.
It works when you have, like, releases sort of longer running, like month-long.
Okay. And that makes sense. Right, so with long-running releases, you have to be able to maintain the past release and apply bug fixes to it and so forth. I think that as you move to a more rapid delivery model, the usefulness of maintaining those separate branches tends to go down quite a bit, and it becomes more complicated than you really would like. So it is a really handy release process, and I think that's a good point to call out, that it's definitely it's hard when you have a longer release cycle. It's hard not to end up with something that looks a little bit like this, I think, as you try to maintain older releases. But as you get more and more into the rapid release cycle stuff, simple releases off of master are probably the way to go. And then we had a discussion earlier about what exactly we're trying to say with this slide. And I think I was trying to make a pun about live people and dead people in Soylent Green.
Unfortunately, Soylent Green is people. But
Soylent Green is people, but they're dead people. So
sorry if we gave a spoiler alert.
Yes, turns out, long story. So anyway, I think the message there, Soylent Green aside, is that to do this properly, you need to be in communication with people. You need to be talking with the folks in your team. You need to be reaching out. it's not just a technical topic, right? We've talked a fair amount about the technical stuff, but the hard part about this is the people part, as always with software. And I think we have a couple minutes for questions.
Yeah, not too much time, but yeah.
The question was, how does code review fit into the everything on master model? Most of the teams I've been on that committed everything on master have done so using pair programming. And pair programming, you have instant peer review. One of the big benefits of the GitHub full model and the notion of using pull requests is that the pull request acts as a peer review mechanism, right? Other people review the stuff that's coming into your code base before it actually gets merged. To me, pairing is a huge benefit. It's something that you should consider doing if you're not. Not everyone likes pairing, not everyone gets into it, but to me, I think it's a really useful feedback mechanism.
I might also lean towards, so code review before merging into master might imply a certain lack of trust in the code. So I would say push it into master, maybe review it after it's done, but like it doesn't have to happen before the merge, and you can always roll it back if there's something wrong. But more often than not, tests and just basically having good developers should avoid a lot of these problems. If there's anything glaring, fix it later rather than.
Step one is have good developers.
Yes, exactly.
Yeah. So that's the trust but verify model, right? That allow people to commit but do a little bit of verification afterwards.
Yeah.
Back there. Okay, so that was a double question right there. The first was, have you guys found any gems to help with the feature flipping stuff? And the second was, why did the Hulk get strangely articulate all of a sudden? And I think the answer to the second question was sheer convenience, because I think it would have gotten really annoying to speak like that for really everyone involved past a certain point. As far as does that square with your?
Yeah, or you could just say you went back and forth between Bruce Banner and the Hulk.
Oh, that's true. Yeah, Hulk calmed down, transformed back, sort of chilled out a little bit. Talked through the pros and the cons. As far as gems go, there are some good gems out there for feature flipping. None of them are really super complicated or involved that I've seen. They tend to be fairly straightforward. You have a configuration file, YAML file of some sort, and some sort of global mechanism for asking whether or not a particular feature is enabled or disabled. I can't remember any names off the top of my head, but I know they're out there because I've done a little research into that before. Do you know of any?
It's called rollout. It's really simple though. We've done. My company's done a bunch of feature flipping and tried to use other libraries, but it's one of those things where the implementation is so straightforward and it seems to be so tied to your particular application that it really, at a certain point, it's like, okay, it's really, really simple. A Redis-based solution is a good one. That's the thing you're going to have in your stack. It's extremely fast to write to and read from, and we have all kinds of different rollouts. Rollout as a new user signs up, rollout, for a set of users, all that kind of stuff.
All right, I think we might be out of time. I see people wandering around and moving, but thank you all very much for coming.
Yeah, thank you.